Welcome to solverfy.
Okay, so we're doing chapter 22, problem 63 here. So we have three very large sheets and are separated by equal distances of 15 centimeters, shown over here. And it says the first and third sheets are very thin and non-conducting, and they have charge per unit area, sigma 1 being the left one of positive 5 microcoulombs per meter squared, and sigma 3 being the right one of negative 5 microcoulombs per meter squared. It says the middle sheet is non-conducting but has no net charge. Part A asks what is the electric field inside the middle sheet. So in an electrostatic situation, there is no electric field inside a conductor, thus E equals 0 inside the conductor, since it's conducting, right? So when there's no net charge on a conductor is what it's saying, there is going to be no electric field inside the conductor. Easy enough, we know E is 0 automatically. Part B, what is the electric field between the left and middle sheets? Okay, so the positive sheet produces an electric field away from itself, right? So it's going to be an electric field labeled E1 pointing this way, while the negative sheet produces an electric field towards itself as well. So we have also a contribution pointing this way from E3. Okay, so the positive sheet here produces an electric field of, just like example 22.7, this is just given by the sigma over 2 epsilon naught. And then we also know that E3 is given the same way, sigma over 2 epsilon naught. And since these are very large sheets, these don't depend on the distance away, which is one interesting thing. We can just take the absolute values because we'll figure out the directions later. We already know from our directional argument that they should be both pointing to the right. So E now is the sum of these two components. So that's just sigma 1 plus sigma 3, absolute values all over 2 epsilon naught. So that just comes out to being 2 times 5 microcoulombs per meter squared times 10 to the negative 6 to convert it back to coulombs, all over 2 times 8.85 times 10 to the negative 12, which is epsilon naught. And this comes out to being 5.65 times 10 to the 5 newtons per coulomb. And we know it's to the right from our directional argument. Cool. Now part C. Part C wants us to do the same thing, but for the other direction. So here we also should see these are going to be pointing in the same direction, all pointing to the right again. So, and since none of the electric fields depend on the direction or the distance away from the sheets, and the middle sheet has no contribution, this is going to be the same as before. So same answer as part B. Cool. Okay, what is part D asking us? Part D says, what is the charge density on the surface of the middle sheet facing the left sheet? Okay, let's actually add a new page here. So to find the charge density on the left sheet, we want to choose a Gaussian cylinder. Looks like this. And this encapsulates the left sheet and as a cross-sectional area of A. So from this, we can use Gauss's law, E dot dA. And what this tells us then is that this corresponds to just negative E A equals charge enclosed over epsilon naught. So from that, we can write charge enclosed in terms of the area density. So this will be E of the left side, since that's what we're trying to find, times the area enclosed over epsilon naught. So now our A's cancel. And we're left with E left equaling negative epsilon naught E. Okay, and this E is what the electric field is between the plates. And we know that that was constant on both sides of the plate, so that's going to be the exact answer we got from parts A and B. So we can just plug this in, 10 to the negative 12, and then times 5.65 times 10 to the 5. And this comes out to being negative 5.0 times 10 to the 6, negative 6 coulombs per meter squared. So this is the left. And now for part E, this was part D. For part E, we want to figure out what sigma right is. But we know that Q net is 0, and this equals sigma left times the area plus sigma right times the area. And the only way we can get this equal to 0 with positive areas is if sigma right equals negative sigma left. So that means sigma right is positive 5.0 times 10 to the negative 6 coulombs per meter squared. Awesome.